the last 2 years, I think, I mainly worked with customers who are doing an architecture that looks like they have .NET on the server and something on the client. That might be .NET, that might be iOS, that might be Android, that might be HTML5, JavaScript, that stuff. You know, that might be even more obscure stuff like set-top boxes, smart TVs, and all these things. And this ultimately leads them to, you know, using technologies which work across all these devices. And that is what we call today web APIs, which is just a fancy name because nobody dares to say web services anymore because that has the SOAP connotation. And then they don't want to call it REST services because they don't know, are we RESTful really? And then they don't want to call it HTTP APIs because that doesn't sound good. So we are at web APIs right now, yeah? But it's basically, you know, it's a web service. And obviously, at some point, once, you know, the initial hype, you know, you're over that, we have to secure that stuff as well, okay? So this is basically my brain dump, what I learned in the last 2 years, building a bunch of these projects and securing them for various, you know, types of scenarios, and I will go over a bunch of them. So my name is Dominick. You know, the usual coordinates here, my blog, my email address. I'm working with Microsoft. We're doing these regular meetings about Web API. So many of the stuff that is in version 2, you know, came from feedback from various people in the community, including me, especially the security stuff in version 2. So I will also give you, we will work on the new version of the Web API in this talk here, which will be released in, I think, 2 or 3 weeks' time. Yeah? Everything I'm showing you is working on version 1 as well, but version 2 does things differently. Okay? Good. So what I want to talk about is basically how we got there, what's my journey to the Web API world. We're going to talk about HTTP security, we're going to talk about SSL, and I want to give you an overview of the architecture, the security relevant parts of Web API, or ASP.NET Web API, I should say. That's the framework I'm using to show it to you, but you can, you know, exchange it with any other Web API framework. They are, you know, kind of feature similar these days. The main part we want to basically be here in application scenarios. I want to show you some typical implementations, some strategies, some things that people do, some things that I think people shouldn't do, and what I think people should do. And that's just a buzzword list here of things you can expect technology-wise in that talk. Okay? Good. So I'm coming from what, you know, people typically call enterprise security. Yeah? So building software for companies, for in-house purposes, or they're selling the software they're building to other companies. And we always had the luxury, or often at least, to live inside of that triangle. Does anybody know what the triangle means? Huh?
The firewall perhaps?
It's Active Directory. Yeah? Or some sort of network managed environment you're living in. Okay? And, you know, security is comparatively easy in that environment because you have the infrastructure. Yeah? You have servers, you have your domain controller, you have your web servers, you have your client machines which are joined to the domain, and you have the users which are actually also joined to the domain, right? I mean, you as an organizational person have an organizational identity, which means you belong to the organization. So there's no really a trust issue here. Everything belongs to the same organization, and we're good to go. Yeah? I mean, at least technically speaking. And the stuff we've been using there, you know, is traditional stuff, Kerberos, LDAP, which, you know, Kerberos is an incredibly complicated protocol, but the fact that it's around for almost 20 years now, we could reduce it to a single checkbox saying enable Windows integrated authentication. Okay? Now, it turns out that, you know, you want to actually communicate with other triangles out there in the world. Yeah? So like business to business, federation, you know, these big buzzwords we had in the last years. And, you know, because it's enterprise, we built hideously complex protocols that only enterprises can understand, yeah, like SOAP and WS stars, WS security, WS trust, WS federation, you know, XML encryption, XML digital signatures, you know, the whole shebang of very complicated stuff. Yeah? And, you know, it turns out that this even worked in some cases. Yeah? So we were building on the XML stack. SAML, you know, the security assertion markup language being a central part here, very, very big in corporate environments. But one thing happened, and I guess our enterprise provider number one, Microsoft, didn't foresee that, or at least they really sucked at doing that, and that was this. Yeah? So suddenly we had devices which, you know, didn't care about the enterprise at all. Yeah? They didn't have SOAP, SAML, or WS star. They don't care. Yeah? They don't have all the fancy stuff. They have HTTP, they have JSON support. That's what they do. And Microsoft said, oh, well, you know, consumer devices. Who cares? Why should we care? Yeah? And the problem was that, you know, the upper management are typically consumers. And they brought in those devices into the enterprise. And suddenly, yeah, we're having the situation that we have to integrate that stuff into the enterprise. And that's typically called a mobile enterprise. Yeah? So I have a number of customers that are actually exactly doing that. Yeah? They give their employees mobile devices. Yeah? Maybe it's the sales force out there that, you know, want to be at the customer with an iPad and ticking off boxes. Maybe it's I have a number of customers which are, you know, run power plants. So people run around at the power plant and, you know, can check the temperature of stuff, which is scary, I think, but they can do that. Or you're just, you know, starting to move your line of business applications to mobile devices. And this gets even more interesting once you have to make the connection from outside the triangle inside your backend. Okay? So many, many challenges here. That is, in my opinion, the one big application scenario we have these days. Yeah? You want to connect mobile devices to maybe existing enterprise backends or backends that you write exactly for that purpose. Yeah? I mean, it's not a secret that the Microsoft client strategy is kind of non-existing. And people are moving to HTML5 and JavaScript for their internal applications. Why? Because they just work. Yeah? And they are not controlled by Microsoft. And it's not a technology which, you know, gets canceled tomorrow. Yeah? So yeah, we have that. And we have the other big, I think, group of scenarios, which is business to customer. Yeah, where you are a company that either builds applications that should be deployed on devices, or you are having services that you want to expose to your customers so they can run from their devices to your back-end services. Yeah? And a very good example of that are banks, for example, yeah? which build their online banking apps, deploy them to the App Store. You can do your online banking on an iPad, on an iPhone, on an Android device. Well, that's a hard one. But on mobile platforms, yeah? Even Windows 8 is sometimes mentioned. So what we have here basically is we have a number of client platforms. And, you know, when you're building a new service today, you can't afford saying, well, it only runs on .NET or runs by using .NET clients anymore. It's just, this era is over. Yeah? You have to build stuff that runs potentially, maybe not today, but tomorrow on an iPad or on a Windows 8 device or in pure HTML, right? So in other words, we have to use technologies which are common denominator technologies over all these devices. And that is not XML, that is not SOAP, that's not Kerberos, that's not WS security. Because Google for WS security support for iOS, you will get not many hits, and the ones you will see are not pretty. Okay? So in other words, this era is over. Okay? Forget about SOAP. I don't want to say it's been a fail, but it doesn't work very well in the new scenarios. Okay? So that's why people are, or at least the customers I have, are starting to build that stuff as web APIs. Web APIs, are very easy to program. They are very easy to connect to. Any device on the planet that can have that has an HTTP stack can talk to these devices, to these backend services. And that's where we are right now. I mean, at least that's what I'm doing every single day. I'm building these systems, and I tell people how to secure them. And that's basically what we're going to talk about. Good. So what I am using, as I said earlier, is ASP.NET Web API. That's just, because I have a Microsoft background, that's what I'm using. But there are many other really good frameworks out there which serve the same purpose. Yeah? I want to mention first and foremost Nancy. If you ever tried, or if you never heard of Nancy, Google for Nancy FX. That's a web service framework. Yeah. If you ever did Sinatra, maybe on Ruby, that's very similar to that, or it's inspired by Sinatra. There's another one called Service Stack out there, and they are all running on .NET. Yeah, they are alternatives to Web API, and they also run on Mono. Well, so there are some interesting scenarios out there. But for our discussion here, I want to use Web API, which is a very, very good Web API framework, in my opinion. And the other interesting story here is that, as you can see, Web API is designed to be hosting independent. So Microsoft is getting away slowly from their ASP.NET hosting story. Even if it's called ASP.NET Web API, that's a pure marketing thing. Web API doesn't have a dependency on system.web.dll anymore. Yeah, and that's a big thing for Microsoft, yeah, because everything else they build has a dependency. HTTP context, HTTP request, HTTP response, all these things. Yeah? So there's no dependency on ASP.NET itself anymore in that framework, which means you can run it in IIS, you can run it on the command line, you can run it in an NT service. I've seen people running it on Mono on a Raspberry Pi. Okay? So that's, the story here. There's a big move to a new hosting infrastructure at Microsoft called OWIN. Maybe you heard that, or the Katana project, which is Microsoft implementation, where you have much more hosting options than today. And basically, the next version of Visual Studio ships with this new OWIN hosting infrastructure. So in 3 weeks' time, you will have an RTM version of that. So the host, as I said, is replaceable now. And the other thing that we care about is HTTP. And that's the main thing we care about. Everything else should be just an option or an implementation detail, if you like. Yeah? And when I say HTTP, I actually mean HTTPS. Okay? There's no, HTTP doesn't have any security built in. Yeah? Everything that happens in HTTP relies on transport level security. So you have to use SSL. And there's no excuse of not doing it, regardless of what your admin says. Okay? Regardless of what your business owner says. SSL is a requirement. Otherwise, you have no security mechanisms built into this protocol. Okay? Now, the problem is that it seems that SSL and developers have kind of a tough life together. Yeah? So what I did is I asked Google. So when I get this damn could not establish secure connection exception in .NET, what should I do? How do I handle SSL validation errors? Yeah? And that's what I got back. And that's a little bit silly. Yeah? So you get a lot of articles saying how to ignore SSL certificate errors, but not many of them tell you how to deal with them properly. Okay? Now, the thing is this, yeah? If you are like a classic intranet style of developer, that wasn't that much of an issue because you were in the triangle, right? And they had their own security laws. To be in the triangle, you had to, be very special, at least, yeah? But these new types of applications, they are not necessarily inside the enterprise anymore. They are run from a home, they are run from the airport, they are run in the hotel, they are run, in the taxi or at Starbucks. And if you don't do SSL properly, anybody can listen and modify your traffic. That's that easy. There are tools out there, it's 2 clicks, and you are owned. Okay? And it's amazing how many of the big apps out there actually ignore SSL. Yeah? I mean, there have been versions of the Facebook application which simply didn't check for the certs because, you know, sometimes it went wrong, and so we just turned it off. Okay, so that's my advice. Even in the post-Snowden era, where we know that SSL is basically owned by the secret services in the world, there's no excuse of not using SSL. You can still add your own application-level encryption and signatures if you want that, but SSL is the prerequisite. I think I stressed that fact enough now. Okay? Good. So, once we have that secure channel, yeah, through which our HTTP flows, yeah, the security model of HTTP is really, really simple. It's actually just 2 slides. I did talks in the past talking about WS security. It took me like 90 minutes to explain the model. 2 slides here, good thing. The idea is really, really simple. Yeah? Whenever you are doing something on the server and the server says, well, you are not authorized to do that, either because you're not signed in at all, or because your claims don't fulfill the requirements, it sends you back a 401 unauthorized. Yeah, that's it. Your credentials are not good enough. And there's a special header here called the authenticate header, which basically can give the client a hint how the user can authenticate to fulfill the request. Yeah? So for example, in the browser, often this scheme here says basic. And basic tells the browser, open this dialog box to log in, this login dialog box where I can type in my name and my password and then resend it, and maybe that's good enough. Okay? So if you hit enter on this dialog box, what happens is that the browser repeats the request, and this time uses a very special header called the authorization header. Yeah? And again, this scheme here often tells the server what type of credential am I sending, and the credential itself is just the credential, something that can be encoded as a string. Okay? And then the server can check that, make sure he's happy with the scheme, make sure he's happy with the credential. If not, 401. Okay? And sometimes some services do it like this, that after the 3rd time you're trying that, they send back a 403, which is forbidden. Means, okay, you're out now. Okay? Other people use different means of transferring credentials, which I would discourage you doing that. Yeah? Some people use the query string. Don't do that. Okay? Query strings are not very good. They end up in your server logs, for example. People tend to copy and paste URLs from the browser to an email, including the credential. I've even seen them indexed on Google. Okay? So don't do that. Cookies, we'll talk about cookies in a second. Cookies are a valid means of transferring a credential, but it has some issues. The authorization header is special because the browser knows about this, that this is the place where you put security information. So it handles things differently, and as we'll see later, there's a whole specification around that, and I'll quickly show you that as well. So that's the typical flow. You're doing something, you're not allowed, 401, you're resending it, setting the authorization header with the credential, you are in, or maybe not. Good. So who is doing ASP .NET Web API in this room? Okay, so you are all on V1, or have you switched to V2 beta versions already? Okay, some of you? So if you are on V1, that was the whole model of Web API. So basically, there was the host. Yeah? There was Web API has this thing called the HTTP message handler, which is a very low-level extensibility point where you can see all requests going in, going out, and that was the traditional place to implement things like authentication, for example. The issue was with Web API v1, or a fact, that there was no authentication built in. So everything they did relied on IIS. So basically, it shipped with Windows integrated authentication and forms authentication and maybe client certificates. That was it, basically. So they solely relied on IIS or on the host to do all the authentication stuff. So if you want to do anything else, like username passwords, API access keys, token-based authentication, you had to write your own message handler for that, and that wasn't, a piece of cake all the time. We made it easier in our framework, which I'll show you later. But anyways, so after you build that here, there was a thing called authorization filter, and then you hit the actual functionality. Now, the issue was that if you rely on IIS-specific features, you couldn't self-host it because you were relying on the IIS as a host. Yeah. If you build it with a message handler, then IIS didn't know about anything. So basically, in the IIS logs, you couldn't see the user coming in here. So there was like a disconnect between the host and the framework. And they didn't like that, and I didn't like that either. So Microsoft rebuilt the whole hosting infrastructure for version 2. And that looks like this now. So there's this new thing called OWIN, which is the Open Web interface for .NET. It's a new hosting infrastructure that allows you to run web frameworks on hosts. So basically, it's the glue between a framework and a host. So that fits in between. Okay? And they're shipping a number of hosts for that. And the good thing about that is now, if you want to write functionality for your applications and you want to be framework independent, doesn't matter which framework you're using. That could be Web API, could be Nancy, could be Service Stack, and you want to be host independent, so that runs in IIS, runs from the command line, runs in NT service. You would program at this level now, the OWIN level. The good thing is that you typically don't have to, because Microsoft had a very, very big feature focus on security this time, and they implemented almost everything you need already for you. Okay? I'm saying almost, there's always room for improvement, but for the 80-20 cases, you already get what you need in version 2 shipping in the box. Okay? You still have message handlers, so if you have an existing investment in message handlers, they still continue to work, so no worries. Yeah? There's a new thing called authentication filters, which you can use to implement Web API-specific authentication logic. It's almost not that important anymore. And we still have the authorization filter, which basically determines if the user is allowed to do what he's trying to do before we actually hit the controller, before we do model binding, because that consumes memory and CPU cycles, and before the controller code is running. Okay? So if you want to learn more about that, OWIN is not a Microsoft invention. It's coming from the community. Yeah? And Microsoft has an implementation of that called Project Katana. And that's shipping, as I said, in the next version of MVC and Web API. And that's a good article to read. So just to give you an idea, if you are working at the OWIN layer, you can imagine you are working at a very low abstraction layer. Okay? You run on arbitrary hosts and on arbitrary frameworks that are OWIN enabled. Yeah? So what you do is you abstract away HTTP as an iDictionary of string and object. Okay? That is HTTP now for you. The string could be URL, and the object could be your URL. The string could be method, and the object could be post. The string could be request headers, and the object is a list of string arrays for headers which are multi-valued as well. Okay? So it's a very low abstraction layer, and you see that you are interacting with HTTP by manipulating the environment, as they call it. Okay? So that could be a middleware, as they call it, yeah, that does authentication, passes some credentials, sets the server.user environment variable, and that's what shows up later in controller.user in your application code. Okay? So that's, as I said, typically something you don't have to do. We have shipping with Web API version 2. We have shipping, the most important one, JSON Web Token authentication. So the new token format I want you to use starting tomorrow, or today later maybe. We have shipping support for Facebook, Google, Microsoft Live. I always forget of the Twitter authentication. Yeah, we have some other things here, and Microsoft implemented that as OWIN middleware. And middleware, the idea from middleware comes from Node.js Connect or Ruby, Rec. These are all very similar concepts. So in other words, what Microsoft does now is it basically gives you functionality that you can use with arbitrary frameworks running on OWIN. So if you want to do Nancy, you can still use Microsoft's CHOT middleware, or you can still use Microsoft's Facebook authentication middleware and do that with Service Stack or with whatever framework you want on different hosts. So that's a good move in general. Yeah? Good. So that's the classic delegating handler. As I said, they are still working, and they're very, very similar. Yeah? You get passed in a request, you can get a response, and you can look at this stuff and manipulate it and so on. And that was how we typically did authentication in Web API in version 1. Yeah? Because that's not easy, I wrote the one authentication handler to rule them all for you already. It's in that GitHub project here. And the idea is basically that it can look for incoming credentials and map them to authentication logic. Yeah? And as I said, there are some samples around that. So if you are using that today, it still works. If you want to use that tomorrow, it still works. But if you start from scratch, I would rather say start with OWIN than with that approach here. Then there's the authentication filter. That's later in the pipeline. The benefit of the authentication filter is that you have more narrower scoping. So you can say, this controller here uses this authentication method. Another controller uses a different authentication method. Yeah? So basically, since you are later in the pipeline, you have more support for scoping to controllers and even action methods here. I mean, would be weird, but you could say the post action uses basic authentication, the get action uses token-based authentication, if you like. Yeah, I wouldn't recommend that. But yeah, that's something you can be aware of. It's not that important, in my opinion. What is important is the so-called authorization filter. And this is the thing that determines if the incoming credential that was mapped to an identity is allowed to fulfill the request it's trying to do. Okay? And there's this attribute called authorize, meaning the user has to be authenticated to enter this controller. If he's not authenticated, what happens is Web API sends back the 401 to the client, giving him the signal you have to authenticate. You can mark methods as allow anonymous. So saying, okay, this controller in general needs authentication, but for the get method, we allow anonymous access. Okay? And you can do something like this, saying you must be authenticated and you must be in the role foo. And I wouldn't recommend doing that. Yes, I am, in general, not very happy if you start tightly coupling security information with your facade. Yeah, because who will be allowed to call the delete method will change over time. It might be today the role foo. It might be today, a different role. And maybe in 2 weeks' time, it's also the user called John who is in neither of those roles. And when you start baking that stuff into your facade, you need to redeploy the facade all the time, which is crazy. Okay? So don't do that. Yeah? A much, much better approach is to separate out the facade from the authorization policy. Okay? And that is very easily done by writing your own authorized attributes. Okay? So for example, there's something called the premium users only attribute. Yeah? Whatever that means. The facade doesn't care what that means. Yeah? In here, you can basically go to a database, whatever you want to, where you want to pull that stuff off, and make a decision and either return true or false. Okay? When the definition of a premium user changes, you only have to redeploy that piece of code and not the whole application. Okay? And what I did, what is working pretty well for many of our customers is I'm doing authorization based on claims. Meaning, what this attribute is saying here is that the method called put updates a customer. So that is called an action, and that is called a resource. So there is no information whatsoever about who is allowed to call that in the facade. It's just saying, I'm going to update a customer. And what this thing is doing is using the claims authorization manager in .NET 4.5 to go to an authorization policy and figure out, is this user with this claims coming in allowed to update customers? And if that's the case, I return true. otherwise I return false. Okay? So who is allowed to update customers will change over time, but that this method is updating customers will probably never change. Okay, so you can keep that stuff stable and factor out your authorization logic to a different part of your application, which you can independently deploy. Maybe you have a policy store behind that, a database that you can update without even having to touch the code at all. Okay, so again, that attribute here is in our identity model framework. Good. So that's basically the pipeline. Okay, OWIN, handlers. Oh, you have a Nancy sticker. Excellent. OWIN, handlers, authentication handlers, authorization handlers, user code. Okay? So that's basically where we are. And I guess that the ones you have to remember in the future is OWIN and authorization handlers. Okay? These are the two important ones. Good. So now let's take that stuff and put it to work. Yeah? So there are fundamentally two application styles out there. Yeah? I call them same domain versus cross domain, or to make it more clear, classic versus modern. Okay? So same domain, what that means is basically that your web APIs and your consumers are living in the same application. And that is very typically, you're going to some website, you're logging in. That login is a classical server-side login, like forms authentication in ASP.NET. And then you are entering that secured area here. And then you have pages which make AJAX calls into web APIs that live in the same application. Or in other words, in browser terms, in the same domain. Because that's what browsers do. The whole security model is based on domains. Is the source that is calling the target in the same domain? If yes, that's OK. If not, that's not OK. Okay? So let me show you that. So what I have here is basically a standard MVC application. And if I run that, let's run it. So when I click the identity server link here, I'm going to a controller, this controller here, which has the authorized attribute, meaning I have to authenticate, which means in that case MVC is showing me the forms authentication login page. Yeah? When I'm authenticated, I'm grabbing the current principal, move that to my view, and the view renders the claims of that principal. So standard stuff. Yeah? So let's do that. DOM. Okay? And that's my name claim, and that's some claim I added in my application logic. Now, the identity client link here is a little different. As you can see, I'm just returning a view. And that view is, oops, where it is calling an API that returns the claims back to the client. Okay? That's the same site scenario. Yeah? We are in the same domain here. I'm just calling something. And because the server has set the authentication cookie first, that cookie flows back with my AJAX calls. Okay? So in other words, what I'm doing here is I'm doing the same thing. I'm just doing client-side data binding. Okay? What should we see if I click this? Exactly the same thing. Okay? We are in the same domain. We are flowing an existing identity back and forth. It was established on the server, but is flowed back from the client to the server. And from a server point of view, you are the same user, regardless if you are in MVC or in Web API. Or in other words, that's the it just works scenario. Okay? That's how many people build applications today, right? You're starting on the server. You're going to some form. That form makes a validation callback, something like that, back to the server, and shows you a little, red exclamation mark, or maybe they're doing data updates. You know that other hype term, single-page applications, yeah, sparse. Same idea, okay? That's how many spas are built. And that's, you know, that's okay. But there's an issue. So when you are opening the spa template in Visual Studio 2012, you'll get an application that looks like this. Yeah? You have a login page which comes from the server. Then you go to a to-do list, I think they do there. Yeah? That's the new Hello World to-do lists. And then you add items, delete items, and so on. And that's happening exactly like that. You're making AJAX calls from here to here in the same application. Yeah? If you're doing the same thing in 2013, it will look fundamentally different. And why? Because they figured out there's an issue. And the issue is called cross-site request forgery. That's a security thing. Yeah? The idea is this. Yeah? What we just did is we went to our application, we logged in, and got back the authentication cookie. Okay? Now, the nice thing about cookies is that we don't have to care about them, right? The browser sends them automatically to the server. Now, what happens if your user opens a new tab or a new window of the same browser and goes to chinahackshack.com and they make a request to your application? What will happen? They send a cookie. Okay? In other words, a third-party application can remote control your APIs. Yeah? Yeah?
But isn't the cookie just set for my domain?
Yes, yes, and you are contacting your domain. Yeah? So that's an issue. And obviously there are workarounds for that. Yeah?
A cookie's not encrypted for the session, so if they started a new request in China, they shouldn't be able to use your cookie, should they? I wouldn't have thought.
No. That's exactly how it works. Cookies are scoped to a domain. When the cookie is established, it will always get sent back to the domain. That's exactly how our app scenario just worked. Okay? That's the reason it worked. So there's a workaround for that. And basically in MVC and in MVC 4, starting with update 2, you will see this thing called the validate anti-forgery token attribute. Yeah? When you're opening the templates, they are all over your code. Okay? And they have a special version of that called validate HTTP anti-forgery token, and that is for web APIs exclusively. And the idea is this. When you are going to your server page and you're rendering down that form that will do the callbacks to your server, what they embed in the form is a hidden value, a so-called anti-forgery token. That is basically a cryptographically derived key. And they render a related key to that inside of an anti-forgery cookie. Okay? Now, when this page posts back to the server doing a submit, yeah, what will get sent? Well, the hidden field and the cookie. And then on the server side, this attribute here takes both values, runs some math on them, and if they match, you are fine, otherwise you are not fine. Okay? So in other words, if you would do a post back from a different server to that page here, then the hidden value would be missing. Okay? And then you can tell that you're coming from a different domain. Yeah? But how do we do that with web APIs? They don't have forms. They don't have post backs. Yeah? And the way this works is in this spa template, and you can look at that in detail, is they have JavaScript code on the client that embeds the hidden value as a header going back to the web API. Okay, so they have basically, they're doing jQuery, I think. They grab that hidden value and add a header to it called, I don't know, anti-forgery header or something like that. And then, again, this attribute looks at the cookie, looks at the header. If they match, you're fine. If not, you're not. And again, if I would make that call from a third-party domain, then the header would be missing. Yeah?
So if I'm in the browser and I work out what you've done, what's to stop me crafting that header and entering different URLs and get all your customers?
Where do you get a header from?
So if I were to create a JavaScript function, because I know where your header website, so I'm authenticated. If I open a new tab, and I can put in a RESTful request.
Sure.
To get data back.
But you need that value in the first place to make a callback. If you don't have that value, you can't call to the web API. Yeah? And the value is embedded in the page that got rendered. Yeah? I can show you that. So my API here is vulnerable. Okay? So I made a call to my API endpoint and got back the claims, meaning I am authenticated. So when I open a new tab and do HTTPS Rodi to my API endpoint, different tab, could be even a different window, you see I'm authenticated in that different tab. Because I'm not doing anti-cross-site request forgery validation here. Okay? In other words, that is something you have to do, otherwise you're vulnerable. But it only works if you have a server-rendered page in the first place. If you're starting to go the way of complete client-side control JavaScript applications, yeah, like PhoneGap, stuff like that, you don't have that server-rendered page in the first place. Okay? That's why Microsoft doesn't like the approach anymore, and they're moving away from it. And I would recommend thinking about the same thing. So let's have a look what they are doing. So Microsoft and I actually too want to encourage you to think more like cross-domain applications, where the client is living in a different domain than the server piece. Okay? So for example, that could be a native application. They are by definition cross-domain, yeah, because they're not running in the browser. And we don't have these issues in native apps. That could be, as I said, applications that don't have a server backend, which are written in JavaScript and HTML5, but don't come from a server in the first place. Yeah? In other words, the front end and the back end live in different domains. And even if they live today in the same domain, you might even decide in the future that maybe your back end must live on a different domain for scalability issues. Yeah? Maybe you want to scale your back end independently of the thing that renders the UI. And then you have the issue. And many people I know do this hacky thing of putting them in a subdomain, for example, so you can scope the cookies even wider. Yeah? It's not the best choice, but sometimes necessary. Okay? So think of the client and the server as separate entities, just like we did with native applications and back-end servers. And then you are in the cross-domain scenario. Good. So now you can't rely on cookies, and that's, by the way, the thing we want to get away from. Okay, so you have to find different means of authentication. And obviously what many people do first, or think about first, is, well, let's do username and password, like we did all the years before with forms authentication and so on. Meaning, in other words, that you're doing the credential validation inside the application backend. Yeah? And obviously that's a bad decision. That's an anti-pattern. Yeah, today. You don't want to bake in security or credential validation logic into your business logic backends. Yeah? If you have more than one service, then they have to share that logic, and sharing typically means copy and pasting the code. Yeah? Or if it works really well with a shared assembly or stuff like that. Yeah? But it doesn't scale very well. You don't want the application developer to be responsible of authentication. That's not his job. He's doing applications, not authentication. Okay? And the typical thing you would go there is, think about service-oriented architecture. And the funny thing is that service-oriented architecture starts to work since we threw out SOAP. Yeah? Is authentication is a service. Okay? And that is often called a security token service. Yeah? And the idea is that this is a service, a web API, for example, built with only one purpose in mind, doing authentication and providing these services to applications. Okay? And now the application doesn't really care anymore how did the user authenticate. Today it's username password, tomorrow it's Kerberos, and in 3 weeks we need client certificates as an add-on mechanism. Do you want to change your business APIs all the time just because these security requirements change? No, you want to change this guy here, because he is responsible for that and no one else. Okay? So the way this works is that you basically divide your application into two legs. The first leg is you request a token. So you authenticate with the token service, you request a token, and you get back a token. Yeah? And then you use that token. And the way this works is typically you send it along on the authorization header, typically with a scheme called bearer, and then you embed that token. This has some nice features. As I said, one is you don't have to deal with authentication anymore in the business service because that's done by him. The other thing is maybe that the client application is using usernames and passwords, for example. Yeah? And what they get back is a token. Once they have the token, they can basically forget about the password. They don't have to store it anywhere. Yeah? They can scrub the memory where it was in. Okay? And maybe, as we'll see later, these tokens are long-lived. So maybe that token is valid for a workday, a week, 2 weeks. Then you never have to bother again with login dialogues, but don't have to store that password. Okay? Think of Google. Google asks you for login every 2 weeks. That's their compromise between security and productivity. Yeah? If that machine gets stolen or lost, whatever, the time window is finite. It's 2 weeks. And then your login is not good anymore. Okay? Now, the issue is this. Well, many people know this is the right thing to do, but it's a steep curve going through from 0 to that architecture. You need this token service thing, and as we all know, that is a single point of failure. So you don't want to have a single token service. You have 2 at least. They're load balanced. Nobody would install a domain with a single domain controller. Yeah? So you have that issue here. You have to write that code. You have to make it secure, blah, blah, blah. So a lot of stuff to do. Yeah? And there's also a protocol that defines this interaction here and parts of that interaction as well, called OAuth 2. So you have to learn that as well. Wow. I just do passwords. That's much better. Something I can understand is sometimes better than something that I know is right, but I don't understand. So the good news is basically that in Web API version 2, we made it really, really easy that you can start small. You're doing OAuth, doing it right, but not having to set up the whole infrastructure. Okay? And that is done by something called an embedded authorization server, meaning you embed the authorization server into your business service. Well, but you just said you shouldn't do that. Yeah, but that's a good compromise to start with. Yeah? Embed this thing into your service. It's a separate endpoint. It's separate from the application. Okay? You have already the right semantics on the client, namely getting the token first, consuming the token, storing it, caching it, whatever, and using the token. And when you decide that this is growing on you and you need to separate the authorization server or the token service bits from the service, you can do that and just have to change the URL of this here. Everything else stays the same. Right? It's the same architecture, it's just a different token endpoint now. And that is, I think, a very good thing in Web API version 2. So let me show you the actual protocol first. And that is basically OAuth, and it's called the resource owner password credential flow, a very long term. But the idea is this. The client makes a post request to the token endpoint. The client can authenticate, meaning the client software can authenticate if you have this concept of client authorization, and clients are the silicon-based life forms, not the carbon-based ones, which are the users. Yeah? And it makes a post request, says, OK, here's a password, here's a resource, that's optional again, and here's the name of the user, and here's his password. Give me back a token. OK? And what comes back is a very simple response. It's a JSON encoded string, basically saying, here's the access token. That is opaque to you. Just send it the next time you talk to the service. That's the right thing to do. And the service and me, we have a trust relationship here. OK? It will expire here, meaning if you cache it, you know up front when you need a new token. OK? That's the token type. That's basically the thing you put on the scheme in the authorization header. And that's another interesting concept called the refresh token. So typically access tokens are shorter lived. In that case, only 1 hour. Okay? And the refresh token could be a token that can be used to get a new short-lived access token. And refresh tokens are long-lived. Okay? So your Twitter client, for example, yeah, they're using exactly that mechanism under the covers. But Twitter doesn't ask you for passwords all the time. They ask you once. What they do is they go to the Twitter server, authenticate you, get back an access token, get back a refresh token, and whenever the access token has expired, they use the refresh token to get a new access token, which is still better than storing a password. Yeah?
Is there any added security in storing the refresh token than just setting the access token with a long expiration?
Well, refresh tokens basically give you unlimited access, whereas access tokens should always be limited.
Yeah, and what is the added security in the refresh token?
For example, that I can blacklist the application on the server side, and then the refresh token becomes invalid. Yeah? And later on, I can show that how that works. Yeah? Okay. So let me show you that. That's the sample. What time do we have, by the way? Yeah. That's the sample that's in the download link I showed you. So let me show you the client first. It's very simple. That's a C# client in that case, yeah. But you see that basically I split my client in 2 parts. One is getting the token, and one is using the token. Okay? Getting the token is really simple. I've written a class for you called the OAuth2 client. You just pass in the URL of the token endpoint. You pass in username and password, and you get back the access token response, which is a .NET class representing the JSON response coming back from the OAuth server. Okay? And as I said, yeah, if at some point you decide I need a full-fledged OAuth server, just change the URL here. That's it. Yeah? And then, once I have the token, I create my client. I set the authorization header. That's an extension method which sets the authorization header with the token and the bearer scheme. And then you just call your APIs, and that's it. Okay? So, what do I need to do to make that happen on the server side? So this here is using OWIN. So for those who have never seen that, in OWIN, there's a new global ASAX, okay? And it's called startup. Yeah? Basically, there's an attribute here called OWIN startup, and you tell them which is the first method to run when the application domain starts up. This is the thing that sets up the application. Yeah? And as you can see, I'm not doing a lot, but they're passing you in a so-called IApp builder. And the IApp builder is the thing where you can wire in middleware. Has anyone done Node.js here in the room? You know Connect? Yeah, so same idea. Basically, you are wiring in like HTTP modules which are called sequentially in a pipeline. Okay? And the app builder is the thing that holds this together. Yeah? So what I'm calling is configure auth. Here. And there's a pattern here. Basically, they call app.use. And that's an extension method on the app builder. Yeah? And then you wire in the OAuth bearer token middleware. And what this thing is doing is it combines 2 things. It gives you an embedded token service on that endpoint here, and it sets up your API to consume that token coming from that token service. So it does it in one package, which is typically 2 middlewares, but that's combined. Okay? So basically what I'm saying here is, that's my token endpoint. Here's my logic, and I'll show that in a second, how to issue these tokens. And the tokens should be valid for 14 days. And then they are expired, and we need a new token. Okay? And I love that one here, allow insecure HTTP, which is by default false. which is good. I just made it for demo purposes.
You're showing us how to set up our own token service. Is there other people that we can use, like Twitter and Google and Yahoo? Can we freely use other people's token
No.
services?
Token services are always bundled with the application they are protecting. Twitter doesn't know about your services. Facebook doesn't know. They know about their services.
When you say know about, you mean the actions that you can do on your application at the time.
And the keys and so on. Okay, so the exciting part is this one here. That's the so-called OAuth authorization server provider. And this is the minimum implementation. And it even fits on the screen. Okay, so I said that in OAuth that there's the concept of validating a client, and the client is an application. You don't have to use that, it's optional, so you have to just say validated, and that's, arbitrary clients can call into your application, which is what we have today, right? Here, in this method, you do the actual user authentication. Okay, so here you would call out to your database and make sure that the name and the password match with a user in your system. So use something more complex than I do. And then, after that is done, you control what's inside of this access token that goes back to the client. And that is done using claims. So basically, you're creating a claims identity, and whatever you put in there will be inside of the token and be visible to your business logic. Yeah, think of role manager on steroids. So the minimum you want to use is the subclaim. That's called subject. That's the human, that authenticated, and maybe some roles, whatever fits your needs. Whatever you put in there will be valid for 14 days in that scenario. And whenever the client sends that to the service, the service will see these values as the identity of the client. Okay? Good. So let's run the server first. That's by the way, the new look in MVC5. It's all bootstrap now. And the client, what the client is doing, it first requests the token, then it shows the token on the screen. Then it goes to an endpoint in my business service, and that echoes back the claims that the business service is seeing about that user. And what we should see there is exactly our subject claim and our role claim I put in there here. Okay? Let's try that. Here we are. Okay? So now, once we have the access token here, we would store it locally, and then would use the access token from now on to talk to the service, and we can forget about the password and the username. Make sense? Good. So that is one of the so-called OAuth flows. OAuth defines so-called flows that describe the interaction between the client, the authorization server, and the resource server. Okay? And in OAuth terms, this is now called a trusted client. Why is it trusted? No? Because the client is allowed to collect the credentials of the user. In other words, the client is able to see the credentials. And you remember when I mentioned enterprise software? In enterprise software, everything inside the triangle was in the same trust domain. All the software you were building for the enterprise, it was implicitly trusted, right? So no one did have an issue if you open up a dialog with a log on. Yeah, because it's trusted. It's written by our developer going against our own backend. Why would we care? But now think of the App Store scenario, where you are writing software, or where third parties are writing software against your public backend. Do you trust every single developer out there going to the App Store, deploying stuff against your backend? Think of Twitter. Yeah? Does Twitter trust every application out there that they are securely dealing with Twitter accounts? No, they don't. Okay? So in OAuth, there's an additional concept of, I don't trust that client. Okay? I don't want that the client is able to see the credentials of our users. Yeah? In other words, I don't trust the developer, and I want to make sure that he's not doing the wrong thing. I mean, even here, we could say like, yeah, okay, I get that, but I don't get the whole token thing. Let's just store the password, just in case I need it again. Okay? Which would be the wrong thing to do. That's exactly what we don't want to do. We don't want these passwords on local devices, on our telephones, on our iPads, on our browser history, and so on. Okay? And that's why they have more stuff in OAuth. That's what I'm going to show you now. Oh, by the way, the token format is often called JSON Web Token, and that's how it looks like, and I'll show you in a second a real token on the wire. So once you are over this initial hurdle, yeah, of getting into the token-based mindset, yeah, because that is the way to go, your scenarios, might get more advanced. Yeah, as I just said, yeah, many of my customers have this scenario where they have built an API. Yeah, parts of that web API is only available to their internal networks. Yeah, so like their internal clients. These internal clients have a different trust level, obviously, than stuff that is built by outside developers. Yeah. Then they have a public API, for example, and some of these public APIs are used by, let's say, business partners. Some software companies they work with that they build software for their APIs. Okay? For example, as I said, I have this bank customer in Scandinavia. They're having internal software, like their stock ticker, market, blah, whatever. And they have software built by partners. For them, the internal software has the most privileges. Yeah? It can do everything, everything relative to the user's authorization level, of course. Yeah? Their partner applications can do less, but still a lot. And then they have external applications, yeah, like stuff that people build against their public API that is documented, that is, it's a public API, it's made for consumption by third parties. So anybody could write an application that does their stock brokering for them and put it in the App Store. Yeah? They go one step further. They have apps that run on television where you can see your portfolio stock ticker on the television. Yeah? I mean, they are totally different security scenarios. Yeah? And once your stuff gets so complex, then maybe the built-in token endpoint is not exactly what you want. You want to have a separate piece that acts like a traffic cop between all these parties, yeah? Between your clients, between your servers, and between your users. And that is called an authorization server. Okay? And what you can do here is, basically, the idea is that what you have is an application. Yeah? Let's say that's my stock broker application. The application will typically consist out of several endpoints. It's not just a single endpoint, right? You have different APIs, maybe living on different servers that act logically as a single application. Another thing that OAuth brings to the table are so-called scopes. So you can subdivide your application into functional blocks. Okay? So maybe you have, read the stock ticker, read my portfolio, make, do a transaction, stuff like that. Yeah? So you can separate that stuff into logical scopes. Yeah? And then when you have your clients talking to that backend, what they have to do first is they go to the authorization server, say, hey, I am the internal client, I am the iPad client, I am some client, yeah, and I want to have access to the search and read scope. Okay? And then what typically happens, and you all saw that before, is that the authorization server can open a screen saying, hey, hello, Dominic, here's the iPad client, and he wants to read your portfolio. Are you okay with that? And then you say allow or decline. That's the so-called consent screen, and I shall show that in a second. And if that's fine, you get back the access token, and then you use the access token to talk to the application. And what's typically in that access token are stuff like, where does the token come from? For whom is the token for? what's the expiration, what's the human, which client did the request, and which scope did the user consent to. Okay, and that is obviously extensible. Okay, and now you can use that to do client authorization, and again, clients are software, and use that to do user authorization. Yeah.
How does your web service, your web API call, how does it know that the token is genuine, not forged in some way? Does it talk to the authorization server?
No, it's signed.
Okay.
Yeah, it's digitally signed by the authorization server, and that's either a shared key or typically an X509 certificate where you have the public portion and the server has the private portion, and you can validate the signature.
Okay, so is that configured within the web API solution where?
Yes, and I'll show you that in a second. Yep. So, and now this thing here becomes more complex than just embedding a token endpoint into your business logic, right? And I mean, what you can do is, there are a number of methods you can override here. Yeah. So you can come to that model, you see, by overriding more of these methods here. And that's the nice thing with the built-in stuff in Web API version 2. You can start small and grow to be a real authorization server if you need that. Okay? Or use something we built. Okay? So that's something I've been working on with Brock, who is working with me on the open source stuff. And that's a fully fledged OAuth 2 implementation of an authorization server, which knows about clients, knows about scopes, knows about users, knows about applications, knows about key material, all that stuff. Okay? And let me quickly show you that. So, and that's open source, of course. So we can say configure server. Now, we are basically not building any type of authentication inside here. You can couple that with arbitrary authentication systems. So this is using our own STS. You can use Active Directory with that. You can use ADFS. You can use whatever you want. You can even embed a local login form. It's basically a supplement to your authentication infrastructure. It's for OAuth. For Web API authorization. So I sign in here. And basically we have this concept of applications, and we have the concept of clients and of keys. Okay? So let's look at clients first. So here are a number of clients. They need to be registered with us. That's the typical way how you do that. You can create new clients. Clients have an ID, clients have a secret, that's how they authenticate with the authorization server, typically when they want to request a token. And I said that OAuth has this thing called flows, and different flows work for different client types. So resource owner is the thing we just saw. Implicit is for native applications or JavaScript-based applications. Code is for web applications, and client is for server-to-server communication. So you can choose which flow you want to allow. You can choose if you want to allow refresh tokens, and so on. And the application, you know, is basically a container of configuration. It has a name, it has an audience, which is the thing that goes in the token. It has a signing credential, yeah? And it has scopes. So here we have the read, search, write scope. So we can say, okay, the read scope, when we display that information to the user, we say like, okay, do you want to allow to read data? We can specify which clients have access to that scope, yeah? Or if you go to other scope, like the write scope, you can say this is an important scope. You want to emphasize that thing to the user, and less clients have access to that, as you can see here. And that's how you define your APIs in terms of OAuth and authorization, yeah? So, oh, thank you. So, so let's go through this other flow called the implicit flow. And the fundamental difference here is that the implicit flow doesn't expose the user's password to the client application. Okay? So the way this works is basically your client application does a redirect to the authorization server. Either you are already in the browser, then you just do a redirect, or you're opening a web view, an embedded browser in your application. Then you say, hey, I'm this application, I want to have access to this resource here. Give me back a token, okay? And what now happens is the authorization server is just, a web endpoint, yeah? So the first thing that happens is if the user is not authenticated, he has to sign in using some sign-in mechanism. As I said, could be Active Directory, could be ADFS, could be Windows, Azure, Active Directory, could be your local database, yeah? Once that, in this case, it's Google. Once that has happened, you basically show the consent screen. And you all seen that before, right? The application Feedly is requesting permission to view your basic information to manage your Google Reader data. Rest in peace. And then the user can say allow access or not. That's how Twitter does it. Yeah, they have the login view and the, that's down there, the consent in one screen, for example. And another thing I really like is how Evernote is doing it. They can say, OK, I give this application access to my data, but only for 1 year. And then it auto expires that refresh token. And then you have to go through that again. So even if you forget about, even if you forget about that you ever did that, it auto expires. OK? And these consent screens are really, really important, because that's the thing that stands between your users and the data, and the client is in between. Okay? So consent screens are important. That's a nice one here. One brought that up here and tested how many people clicked allow. And obviously, it takes you too long to read it to fully understand what it's doing. Okay? Good. So once the user has clicked allow, the authorization server calls back the client on a registered callback URI and gives him the token here in the query string, or rather in a hash fragment, which is an important distinction. Okay? And then now the client has the token, and from that point on, he just uses the authorization header and puts the X token on the bearer scheme. Okay? Let me show you that in action. Let's close that down. And open this. And again, that's all up on the GitHub site, the whole code you're seeing here. I'm using a native application as the first example. And that's a Windows 8 application. And that's just, symbolic for any type of device application. Yeah? And this is so common now, this embedded web view approach, yeah, that Microsoft has new native APIs to do exactly that. So in WinRT, there are native APIs that open a secured web view inside your application where the caller can't intercept keystrokes or can't save the password that's inside that application. So when I say request token, I open this web view and go to authorization server's endpoint. Okay? That says, OK, you haven't authenticated yet. Authenticate. So I am logging in. And now we're going to authorization server, and now it pulls all the data, yeah, like my application description, my scope descriptions, my, should that be emphasized, and should I remember that decision, for example? Yeah. So I don't want to see that screen again next time. Yeah, all that stuff. I click allow. And I have my access token in here. Okay? And now I said I want to show you the access token. So let's do that. There's a nice token debugger. And you see that's basically the standard token you get. That's the name of the issuer, the name of the application, not before expiration, the name of the client, the name of the user, the name of the user, and the scope that this user has consented to. Okay? And now we're using that token to talk to the actual API. So let's do that. Access the resource. And this is just echoing back the claims that we've just seen here that were inside of the token. Okay? And now the application could store that token and hold on to it. In fact, that's what I'm doing actually. Yeah? So when I close that down and run it again, you see it's still there. I can exit the resource without having to re-authenticate the user. Okay? And then I can clear it at some point. Let me show you the same. Oh, yeah. Let me quickly show you the source code. It's actually here. So what I'm basically doing is I have to construct this URL. Yeah? So I have to pass in my client ID, the scope, and the callback URI. Yeah? That's the thing where we know if successful, that's the URL which has the access token coming back. And then you see that here, Web Authentication Broker, that's the new Windows 8 API that opens this web view. And that's coming actually from, you see that, windows.security.authentication.web. So that's a built-in API. Other platforms have similar things. Xamarin has the web view. iOS has web views. Android has web views. So this works on every client platform you can imagine, okay? Which is part of the mission statement. So let me show you the same thing in JavaScript. That's here. Let me show you the page first. You see, actually what I'm doing is I'm doing the same thing. I'm constructing the URL to the authorization server and then do the redirect here. Yeah? So we are already in the browser. We don't have to open the browser. And on the way back, on the callback URL, you see that there's some funky code going on extracting the token from the URL. And ultimately, this is how you send the authorization header in jQuery. You say, before sending that request, call that function, and this function sets the authorization header with the token that we got back from our authorization server. Okay? So let's run that. Okay? So again, we are here. I'm logging in. And you know, depending on how you want to have that, we could set a cookie now here. Here we are. I could remember the decision. Allow. Here's the token. Yeah. Oh, let's do it again, just to show you. Now, since I now have a login cookie, and I remember the decision, yeah, something's wrong with the name resolution here right now. Come on. That's weird. Do this. Let's try that. Yeah. Okay. So no user interaction, at least for a specified amount of time, unless the login cookie has expired. Okay? And now I can call the service. Wow, doesn't work. That's weird. And that's just to show you another security feature you have to be aware of, and it's called CORS, Cross-Origin Resource Sharing. So I said earlier that the browser doesn't like you to do calls from domain 1 to domain 2. But this is a very, very common scenario. Yeah? And this wasn't allowed, and people got really creative overcoming that limitation. For example, changing the domain name so they are in the same subdomain. JSON-P is another way to get around that restriction. And CORS is kind of the official way of doing it. Yeah? So cause is a W3C specification. You're doing the call from server 1 to server 2, and the browser doesn't like that. So what's happening under the covers is, before doing the actual call, the browser sends an options request to the endpoint you're trying to access. Okay, and it basically says something like, hey, I'm going to make a post and my origin is server 1. Do you allow me to do that? Okay, and now you have some policy running on your service and say, okay, do I allow this or not? And if yes, you basically say access control allow origin server 1. And if that comes back and the browser compares these values, he will do the actual request. Okay, which means you have to have some server piece which orchestrates these interactions. Okay, and by the way, you can go very, very fine-grained here. You can say I allow post from server 1 and get from server 2, and I allow these request headers. I allow the authorization header to be sent, stuff like that. So you can go very, very fine-grained here. Yeah, and in version 1 of the Web API, there wasn't an implementation of that. And that's what we did. And you know that ASP NET is open source now, so you can contribute. So if you have a great idea, you can talk to Microsoft, say, hey, here's my code. Want to have it? Yeah? And that's what we did. And now our stuff is now system.web.cause. Okay? And the way this works is you have to enable cause on the controller or globally and have to provide a policy. Okay? And the policy means which origins do I allow, which headers do I allow, which verbs do I allow. And if that's too fine-grained, you can put stars in there as well. 1 second. So with that in mind, let's go back to our code. Go to our controller and add the enable cause attribute, which says I allow this source. And now I can retry. Oh, by the way, the browser will only give you a 404. So you don't know why your request has failed. Okay? But if you're looking in here, you see not allowed by access control. Okay? That's how you can diagnose these things. So, okay. Let's try it again with our new attribute, and here we are. Okay? In other words, that's another thing you have to add to your skill set if you're doing JavaScript-based applications these days. And the very last thing I show you before I do questions is how did we actually validate those tokens here? Yeah? And again, I'm using OWin for that. So here's the middleware. It's called app use bearer tokens. Yeah? You pass in the required issuer name, you pass in the required audience, and you pass in the signing key that you use to validate the incoming token. Okay? And if all these three things are valid, then the token will be accepted and gets turned into a principal, and from that point on, your code is just running as normal. That's again part of the new middleware that Microsoft is shipping as Web API version 2. So that's all you need to do here. Question?
When the authorization server receives a request from the client, presumably being triggered by your resource server, how does the authorization server know that it was your resource server and not a spoof?
Okay. So the question is for the recording, how does the authorization server know that it's the right client? Because, I mean, the thing is that there is no redirect happening. That the resource server is out of the picture here. I first contact the authorization server and then the resource server. There is no redirect going on. Yeah?
So, I guess what I'm getting is how does the authorization server know to tell the client that you are in roles X, Y, and Z that are specific to?
Okay. The authorization server has a trust relationship with your authentication system, obviously. Yeah, so it's either Active Directory and you can pull the Windows groups, or it's ADFS and you can pull the claims, or it's whatever, it's your local login form and you pull them from the database. The authorization server conceptually doesn't do authentication. It's just using the outcome of the authentication to create an access token.
But is the browser support for CORS?
Yeah. That is, the question was, what's the browser support for CORS? And that is like the sad story here. There's one browser, unfortunately, that doesn't support it properly. Guess who?
But isn't that open source also now? No?
IE?
Yeah.
No. So IE, starting with version 9, supports CORS. But unfortunately, especially in corporate environments, you have IE 8 deployed quite a bit. And you can get around that by putting the target server into the trusted zones in IE 8. But that is a big trust decision, and you only want to do that for intranet scenarios. Yeah? Yeah. Yeah.
Are there ways of doing the same thing in earlier versions?
Of Windows? Yes. So the question is, what do I do if I'm not on Windows 8? So every platform has its own way of embedding a browser. So WinForms has a browser, WPF has a browser, Android has one, iOS has one. So yeah, you can embed a browser into your application. In WPF, it's the WPF browser control.
In a secure way?
Well, what does secure mean here?
Such that the application can't see the credentials that are being...
No. I mean, on Windows desktop, you are in the wild, wild west. I mean, the thing is this. The user already installed that application on his client machine. That was the trust decision he made. Other platforms that are more restricted, are more vendor controlled, like Windows 8 or iOS, can make it harder. But desktop Windows, Android, no.
How does the claims transformation work?
Okay, good question. What's claims transformation? The idea of claims transformation is that you're taking the claims that fall out of that token validation, run it through your own logic, and maybe replace some claims, add some claims, remove some claims, whatever. Yeah? And if you watch closely, you always saw in my demos the claims from the token plus local claim and local value on the bottom. And that is coming from my claims authorization logic. Yeah? And that is basically a class that ships with .NET 4.5 called Claims Authentication Manager. They pass you in the incoming claims principal, and you return some other claims principal, and that's where I added my application local claims to the identity. Yeah? The middleware is not part of the web API, but it's part of the sample. I wrote the middleware for that. Any more questions? Well, for example, maybe, user Dominick is coming in and you want to add some local application data to the identity, maybe like his first name, last name, so you can say, hello, Dominick, stuff like that. I mean, stuff that is application local. Yeah? And that basically, this code runs after the token has been validated and the identity is established, and then you can change it in a way that it makes sense for your business logic code.
Augmenting your data.
Augmenting, replacing, removing stuff that isn't relevant, stuff like that. Yeah. Okay. Good, then thanks for your time. Enjoy the rest of the conference, and I'm around. If you have questions, just, catch me. Thank you.